So today I want to talk about the concept of variance in ecology. And I like to think about this from the beginning point. So let's say, for example, that you were out doing something wild and fun, like you're traveling the world with your friends and you're off at perhaps in England and you're at the far edge of the furthest point out into the ocean and you found yourself a pub, you settle down in there and you enter into a game of darts. And in this game of darts, there are no rules set forth before the game begins. You just play, you aim for the middle of the board, you try to hit the target, and then once the game has been played, it's a bit of a discussion about who really won the game. And I like this because you don't need any tools. You can't have a calculator, you can't have a book, you don't have the internet. You have no other way of determining who the winner is except by simply coming up with a standardized measurement tool that can measure the score of each of the dart players. So I have two fictitious dart players that I've brought out here. This is Kelly and Carrie's scores, and I've scored them on the board here. Now, in order to do this, I've made my dartboard flat and unidimensional, so it goes like this. All right, and the score we're aiming for is the 5 in the middle. And so they've thrown their darts, and what I've done is I've scored with these red arrows up here where exactly their darts fell. And so Kelly's score, you can see, she did score one bullseye in the middle. Her other ones were in a very regular pattern right around that. Carrie's, on the other hand, she also scored a score in the middle here on the bullseye, which was the 5, but she has a much wider spread of darts. And so what I want to think about today is, say these people, or maybe you and someone else, and you're in a bar, you really want to figure out, like, gosh, how can I justify winning? Because maybe you're going to get a free sheep or something, whatever they give out in bars in England or pubs, right? And you really want that free sheep because you don't have one. And so how do you measure these in such a way that you can quantitatively compare them? And the first thing that people think about, I think, is something called what is the largest distance between the darts? And we can look at that as this distance here. And that would be, for example, 7 minus 3. And this measurement actually has a formal name. It's called the range. The maximum minus the minimum score. And we could also measure that range down here for Carrie's score. And her score would be 9 minus 1, 8. So the range for Carrie's is much larger, the range for Kelly's is much smaller, and in this case we could justify Kelly as having a better score because, as you can see from these, they both have a mean score of 5 and they both hit the bullseye. All right, so other than the spread of points, we don't have much to work with. This is a good measure of spread, but it doesn't tell us a lot about the individual points within here. So I'm going to move over to another way of looking at this. I've taken these scores and put them into two lists here. So this list is Kelly's score and Carrie's score, and in this way I'm also going to label these observations, and I'm going to label them with what's called the X sub I. So each of them is observation X. This is X sub 1, X sub 2, X sub 3, X sub 4, X sub 5. Now you're often going to see this X sub number function, a variable somewhere, and it labels which observation we're looking at. We will need that in a formula later. So one thing we can do with these numbers is take the average, and if we take the average of these numbers, we add them all up, and we divide by the number of observations. So the average can be written like this. The sum from I equals 1 to n, there are n observations. So this is the first of the n's, and this is the nth of the n's, right? And the sum of all the observations, all the x sub i's, we're going to divide that value by the number of observations, n, okay? And this sigma means we're going to sum the first one, plus the second one, plus the third one, plus the fourth one, plus the fifth one, and divide by the number of observations. And this value is going to equal 25 over 5 equals 5 for Kelly's score over here. The 5 we often call the average, or the mean. They mean the same thing. And in this case, it's labeled with the letter X bar. And I'm going to write that down here. X bar is equal to 5. All right, so that's her mean score. We could do the same thing with Carrie's score. We're going to add them up here. And if we add them all up, they should equal, let's see, 4 and 5 is 9, and 9 is 18, should be 25. Over 5 again equals 5 equals X bar. All right, now I'm going to clean this up a little bit, so I'm going to erase some of these things. I do this for the purpose of making room for the rest of our calculations. X bar equals 5, X bar equals 5. Now, the next way we might look at how to measure the spread of points would be to simply look at the scores and say, gosh, why don't we add up how far away they are from the mean? Let's go over here and take another look. So for Carrie's scores down here, what we would do is say, well, this one is two units away, and so that's 2, and this one's 1, 2, 3, 4 units away. So we would add the 2 plus the 4, and this is under on this side, so this is down by 2 and down by 4. So we could add all those numbers together. And that would give us a measure of how far away total were Carrie's throws. And so we're going to call this the deviation. So we're going to subtract the mean from these numbers. And this 3 minus 5 equals -2. 4 minus 5 equals -1. 5 minus 5 equals 0. 6 minus 5 equals 1. And 7 minus 5 equals 2. Now, there's an intrinsic problem here, and that is when we add all these numbers together, they of course equal 0. And this always happens when we're using the mean as that center point, because the mean is by definition the middle of those numbers. So what we can do in one case is take the absolute deviation. So we can absolute value all of these terms, and that will get rid of the negative sign. And then when we add them all together, they will then be 2 plus 1 is 3 plus 3. This will be 6. All right, and I want to take I think it's a total deviation, but given the number of dart throws, if we throw more darts, this number will go up. So let's take it as an average per dart, all right? So that would be 6. I will divide it by n, which in this case, which is 5, and we'll get 1 and 1/5, this is 1.2, is the, this would be the mean absolute deviation. Mad. Now we can also calculate MAD for Carrie's score over here. And to do that, we also subtract the mean. And then we see 1 minus 5 is -4, 3 minus 5 is -2, 5 minus 5 is 0, 7 minus 5 is 2, and 9 minus 5 equals 4. And so if we take the mean absolute deviation of these numbers, then we get 4, 2 is 6, and 6, this is 12. And if it's the average of those, right, so 12 divided by n, which in this case is 5, observations, we get 2.2, 2.4 actually, 2 2/5, okay? And so this total number is the mean absolute deviation. And we can compare those. And you can see in this case that this person, Carrie, has a much larger absolute deviation as compared to Kelly's score. Now the next thing we can do is take a look at a different way of getting rid of these negative signs without having to use the absolute value, because it's kind of arbitrary to go and get rid of them. So one way of doing that is to square those numbers. Any number squared is always positive. So I'm going to put the square here. So in this case, I'm going to take the deviation from the mean, which is there, and I'm going to square that number. And so 2 squared, -2 squared is going to be 4. 1 squared will be 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So in this case, I've got a nice list of numbers here that are all positive, and they can be added up to represent deviation squared. 4, 8, that's 10. So I need a little space down here. I'm going to put it right here, 10. To make it the average deviation squared, I'm going to divide by n, which in this case will be 5. It's kind of a funny looking 5, isn't it? Let's fix that. That's 2. 10 divided by 5 is 2. This number is much larger than the mean absolute deviation, but that's because we squared numbers instead of just taking the absolute values. So we can do the same thing with these numbers over here. We can take the square of the deviations, and this is 4 squared is 16, 2 squared is 4, 0 squared is 0, 2 squared is 2, 4 squared is 16, okay? And again, I'm short on space here. We can put this number down here, and this is 16, 16, 32, and 6 is 38. Divided by the number of observations, which is 5, is going to be equal to 7. 7 times 5 is 35, and 3 is 7.6. Okay, so this then becomes the average of the squared deviations from the mean. The average of the squared deviations from the mean can be written ASDM, And the average squared deviation from the mean is exactly the measure that is called the variance in statistics. So the variance here. So the variance is something you could come up with on your own in an Irish pub or an English pub for a sheep.